Hey everyone, and welcome. So you've built your awesome new application, but there's a problem. It's kind of slow. You did the smart thing and put in a cache, that secret weapon for lightning-fast performance. But what happens when that cache gets totally full? Which data do you keep and which do you toss out? All right, let's get into it.
Here's the game plan for today. We're going to kick off with a quick refresher on what caching is all about. Then we'll dive deep into 3 core strategies: the super simple FIFO, the very popular LRU, and the meticulous LFU. And to wrap it all up, we'll figure out how on earth you choose the right one for your project. Ah yes, the question that probably keeps a lot of us developers up at night. Why is my application so slow? You know, a lot of the time, the bottleneck isn't your CPU. It's the time it takes to go fetch data from a database or some remote API. In that world, every single millisecond counts, and that is exactly where caching becomes your absolute best friend. So what exactly is caching when we talk about it? Well, think of it like this. It's basically the technique of storing data you use a ton in a temporary, super fast spot in memory. It's like putting your favorite tools right on your workbench instead of having to walk back to the big toolbox every single time you need a screwdriver. The goal is dead simple. Slash that latency and take the pressure off your main database.
But, and there's always a but, right? Here's the problem you're guaranteed to hit. Your cache isn't infinite. It's a workbench, not a massive warehouse. So eventually it's going to get full. And the moment you need to add one new thing, you have to make a choice. What gets kicked out to make room? This right here is the whole game of cache eviction, and the strategy you pick can make or break your app's performance.
So let's kick things off with our first strategy, and honestly the simplest one of the bunch: FIFO. That stands for first in, first out. And as the subtitle suggests, it's really just a simple queue.
You know, the best analogy for this is just a line of people waiting for a bus. FIFO works exactly like that. The first person who got in line is the first person who gets on the bus and leaves. It doesn't matter if they're a VIP or if they ride the bus every day. They got there first, so they leave first. It really is that simple.
And the mechanics are just as straightforward. Your cache is just keeping a list, a queue. A new item comes in, it goes to the back of the line. Your cache is full and you need some space. You don't do any fancy math. You just boot the item that's been sitting there the longest, the one at the very front of the queue. Gone.
So what's the trade-off here? Well, the big pro is that FIFO is incredibly easy to code up. You can get it working in no time. But the con? Oh, the con is a big one. It's often really inefficient. Just imagine you have a critical piece of config data that your app needs all the time. It gets loaded when the app starts, right? So it's at the front of the queue. Even if your app asks for it every single second, the moment the cache is full, FIFO will kick it out just because it was the oldest. That's a massive performance hit waiting to happen.
That major inefficiency in FIFO leads us right into our next strategy, one that tries to be a whole lot smarter about what it keeps. And that is LRU, or least recently used. This is the popular workhorse of caching algorithms, and for a very, very good reason. The best way to get your head around LRU is to picture a messy pile of papers on your desk. The stuff you were just working on is right there on top. The papers at the very bottom, you probably haven't touched those in weeks. So when it's time to clean up, you naturally just grab that stack from the bottom and toss it. LRU does that exact same thing, but with your data.
So operationally, it's definitely a bit more involved than FIFO. Anytime an item is accessed, whether you read it or write to it, it gets promoted to the most recently used spot. Think of it as being moved to the top of the pile. Then when it's time to evict something, we just remove the item that's been sitting at the very bottom of that pile the longest. For you Go developers out there, the classic way to build this is with a hash map for those blazing fast O of 1 lookups paired with the container/list package, which gives you an efficient doubly linked list. That combo is key to avoiding slow operations.
Now, LRU is so popular because most of the time it works really well. The core idea that data you just used is data you're likely to use again soon is true for a ton of applications. But it does have an Achilles heel, something called cache pollution. Imagine you run a big one-off report that scans 1 million database records. Every one of those records is accessed once, right? So they all flood your LRU cache, pushing out all the actually important, hot data you needed to keep. That one scan pollutes your cache with useless, single-use items, and for a while, your cache's performance is totally wrecked.
And that potential for pollution brings us to our third contender, LFU, or least frequently used. I like to think of this one as the meticulous accountant of the caching world. It keeps track of everything.
The perfect analogy here is a library trying to make some space on the shelves.
A smart librarian isn't going to get rid of the popular book that was just returned yesterday. No way. They're going to look at the records and find that dusty old book that nobody has checked out in 5 years. LFU runs on that same exact principle. It cares about long-term popularity, not just recent activity.
So how does it actually work? Well, it's all about keeping score. Every single item in your cache gets a little counter. Each time you access an item, you just increment its counter. Then, when eviction day comes, the algorithm scans for the item with the lowest score, the least popular one, and that's the one that gets the boot. It doesn't matter when it was last used, only how often. And of course, this adds some overhead, because now you have to track and manage all those counts.
So LFU can definitely outperform LRU when you have items that stay popular for a long time, even if they aren't accessed constantly. But it comes with its own set of pretty tricky problems. First, there's the new item problem. A brand new item comes into the cache with a frequency count of just 1, which makes it an immediate target for eviction, even if it's about to become super popular. And second, it can hold on to old favorites for too long. An item that was a huge hit last month but is totally irrelevant now might just sit there, clogging up your cache, because its frequency count is still sky high. These are serious issues to think about.
All right, we've seen the simple FIFO, the popular LRU, and the meticulous LFU. Now we get to the most important question. Which one do you actually choose? It's time for the final showdown.
Let's put everything on the table and see exactly how these three strategies stack up against each other. What are the core differences that are going to help us make a decision?
Okay, let's just run through this. For FIFO, the eviction criteria is simple. The oldest item gets kicked out. Pro, super easy to implement. Con, it's not very smart and can evict popular items. Then we have LRU. It evicts the item that was least recently used. Pro, it's effective and a go-to for many. Con, it's more complex and it's vulnerable to that cache pollution from big scans. And finally, LFU, which evicts the least frequently used item. Pro, can be more effective than LRU in some cases. Con, it's complex and it has those tricky new item and historical data problems. This table right here is basically your cheat sheet.
And this brings us to the most important takeaway of this whole thing. There is no single best algorithm. Anyone who tells you to always use LRU or something similar isn't looking at the whole picture. The right choice depends completely on your application's specific data access patterns. Are you caching user sessions, configuration data? The answer to what you're caching is what will point you to the right eviction policy.
And that leaves us with one final provocative thought. We've spent this time comparing LRU, which cares about recency, against LFU, which cares about frequency. But what if you didn't have to choose between them? What if you could combine the best of both worlds? Well, that's where really advanced algorithms like WTinyLFU come into the picture. But that's a whole topic for another explainer. Thanks so much for watching.